is better. What if I go from N4 to 8, and then to 16, and then to 32, and then to 128? Which of these will be better? The 8, the 16, the 32, the 128.
The 128.
128. So what does this mean, really? What does it say? Whenever we increased something, what operator did we use? What operator did we use when we said, oh, it goes to 8 and then 16 and then 32 and then 128? Maybe infinity. We used an operator from chapter 1. We constantly use this operator. We liked it or not, I don't know, but we used it all the time. What operator did we use? The what? We used it in test 1. We had to use it the day before in test 2 to determine vertical asymptotes and horizontal asymptotes. Is a very important operator.
Limit.
Yes, the limit operator. See, as the number of subintervals increases, so then the limit of areas of rectangles as n approaches infinity, this will be indeed the exact area. Guaranteed. No approximation. So when we determine the limit of all these areas, we will get the exact area. Guaranteed. Don't get scared. We're not going to use the limit operator. We are going to use, sorry, I did not get the chance to put this in order. We are going to use, I just wanted to clarify it. I'm going to write it. We are going to use the definite integral. So I'm going to put it here. We're not going to use it right now because we're going to work on a problem with approximation. But the exact area will be the definite integral. I'm going to write it here for our example. Remember, f of x was x squared plus 1 and the interval 0, 2. I want you to see it now so you, from the very beginning, you understand the difference between the two integrals. The definite integral will be the same, no change except to 1, from 0 to 2. It's the sum of all areas of rectangles from the function dx from 0 to 2. So this will be, we're not going to use the limit on these. Okay, I'm using the limit with my STEM class a lot, but in this class we directly go to the exact area determined by evaluating the definite integral. So what's the difference between these two symbols? One symbol gives us a family of functions. The other symbol, definite, from 0 to 2, will give us a number. Which will be exact area under the graph, if the function and so on and so forth, but it will give us a number. Okay, so we still have time. I would like us to choose a problem. We are on page 402. Okay. We can approximate from a graph that we are given or we can create our own. Would you like to choose 19A or B, or do you want us to choose or create our own work on a function?
We could do 19.
19, okay, perfect. Let's look at 19A. So approximate the area under the following graph. F of x goes 1 over x squared, and the interval is 1, 7, by computing the area of each rectangle to 4 decimal places and then adding. So looking at this graph, can anyone identify if it's the leftmost point or the rightmost point?
It's the leftmost point.
It is the leftmost point. Awesome. And they want 1, 2, 3, 4, 5, 6 subintervals. So the area with the leftmost point with 6 is approximately. So the first rectangle, what is the base? And what is the height? The base is 1 times the height. So I'm not going to write the base again because it's all 1. So I'm just going to write f of 1 plus, can anyone tell us what else we have to write? For the next rectangle, what is the height?
2.
No, the height is, it's not 2.
F of 2.
F of 2, very good. Plus, for the next one.
F of 3.
Yes, and of course f of 4 plus f of 5 plus f of 6, and that's it. Please do not write f of 7. F of 7 will be the next rectangle. So 1, 2, 3, 4, 5, 6. Careful here, do not calculate 7. F of 1, first rectangle. F of 2 is the height of the second, the third, the fourth, the fifth, and the sixth. Good. So 1 over 1 squared, 1 plus 1 over 4 plus 1 over 9 plus 1 over 16 plus 1 over 25 plus 1 over 36. And that is it. So with a graphing calculator, I'm just going to put that in. There is a more elegant way of doing this. I can show you if you want. But right now we just have 1 plus 1 divided by 4 plus 1 divided by 9 plus 1 divided by 16 plus 1 divided by 25 and finally plus 1 divided by 36. I'm going to change it into a fraction. See what you get. So we get 5369 over 3600. And we can approximate 1.4914. So we determined the area under the graph of 1 over x squared, approximating it with using the leftmost point and 6 rectangles. They were all with the same length. I'm sorry, width. So I didn't put it in because it was 1. But if it's any other number, I have to put it in. It just happens that 1 multiplication by 1 doesn't change anything. So this is how we calculate the area under the graph, which is the same with total distance or total revenue, or let's look at a word problem. If we don't finish it tonight, we'll finish it on Monday. Okay, so again, something like what we just did. For example, total cost from marginal cost. So we have the marginal cost, but they're not asking us to find the cost. No, they want us definite, specific, definite, where X is the number of pounds. Find the total cost of roasting 200 pounds. Okay, from 0 to 200. So and they want, so let me copy that. So that's, I'm on page 11, so 31. Okay, so we have C prime of x, negative 0.007 x plus 12. And, oh, I copied something else. That's fine. Okay, so I was looking at 30, so I'm going to copy 30. It doesn't matter. C prime, negative 0.012 x plus 6.5. Plus 6.5 for x less than or equal to 300. Okay. Where x is, okay. Find the total cost of roasting 200 pounds. Okay. Good. So, first of all, let's find C. C of x. Can anyone tell us how to find C of x? Nobody can understand my handwriting. So, of course, no one can say anything. Let's look again. Yes, 6.5 for x less than 100, where x is the number of pounds of coffee, find the total cost of roasting 200. Okay. I can show you directly, we can, how to determine a definite integral directly. Or it doesn't say to us, calculate total cost disregarding any fixed cost or total profit. So it doesn't tell us how many rectangles to use. It says the marginal cost is given to us, and find the total cost of roasting 200 pounds of coffee. So let's find the cost. So I have negative 0.012, which function prime is x. You already told me several times tonight, plus 6.5 x plus, I don't want to use, I don't like to use a constant c when I have c, so I'm going to use d, just not to be confused. This is just a constant. Okay, so c of x, the cost of x, is negative 0.006 x squared plus 6.5 x plus d. And we're asked now, find the total cost of roasting 200 pounds of coffee. So what do we do? Any suggestions?
You plug 200.
So
there's x.
So let's, okay. So, but then what do we do with d? So it's a good point, very good point. But in our situation, we assume that when x is 0, d is 0. Or c of 0 is also 0, right? So we have to make that assumption, and then I completely agree with you. So c of 200. So I'm going to put it directly in the calculator. Because if we don't produce anything, we don't have a cost. So we have to make that assumption. So negative 0.006. You know me, I don't like to do this. I like to put in the function so I can see it, but okay, for now, squared plus 6.5 times 200. So 1060.